Cool. All right. I think we're good to go now. All right, so this is going to be a little bit different from last time. Let me just verify we're live in the browser. Sick. Cool. All right. I think we're good to go now. Sound's coming through. Checks out. Dope. You know what I should have done beforehand? Sorry about that. I need music. Gotta have a little bit of that music that we had last time playing. Ooh. It was good and didn't come up as a copyright, which is far more important. There it is. Okay. How's that coming through? Let me see. Okay. Well, that does that. Oh. How's that coming through? Okay, yeah, it's not bad. It's not terrible. Let's see. It's not good. It's not great. Sick. Okay. Right, so today we are going to mess around with this robotic arm. I need to adjust this camera so we can capture this. You're just gonna have to bear with me. I don't have like a complete setup for all of this. Like straight up using another phone I had for this face cam, and then this guy here is an Xbox 360 live. Here, let me show you. This thing is ancient. Ah! Oh my goodness! Check it out. Oh, you can barely see it. Look at this Xbox 360 live cam. Oh man. Throwback. Okay, I think this will work. Basically, I'm just trying to get it so we can see the arm moving. So this is a robotic arm. It has a servo down here. It additionally has another servo right here and another one here. So we have 3 areas to pivot, or like we can rotate the base, and then we can pivot here. We can pivot here, and then this guy is a DC motor on like one of those. It looks like I don't know what you call it, an elongated screw. So eventually we'll plug that up, and there'll be the ability to like grab stuff. As far as the brains of the unit, it's pretty simple. It's just an it's not going to focus. It's an ESP32 module. What this is basically like an Arduino, but additionally it has a Wi-Fi chip built onto it, which is super awesome. So this little Wi-Fi chip has the ability to be a router as well. I shouldn't say a router. I should say an access point, a wireless access point, a WAP. And that's really cool because we can connect our phone to it. Now, moreover, we can connect a browser as well. But moreover, it can run servers. So I can connect to this ESP32 over Wi-Fi, and then I can have this ESP32 deliver web pages. Now, when it delivers a web page, we're good to go. You know, we can throw some JavaScript in there, some HTML, CSS, whatever, and then we can listen. We can host a server on this guy as well, and it does a lot. This is some neat stuff. And this essentially becomes our backend as well. So currently, how I have it set up is the phone will Oh, that's how I'm testing right now, is with a phone. But you connect to it, loads a browser, and then from there you have X, Y, and Z axis controls. And over WebSockets, when you move the slider, it sends that information real time over WebSockets to the ESP32 module, and that makes the arm move. So let's power this up and let's test it out. What did I used to power this guy? Give me a second. What would I use for data? I feel like I had a cable nearby. I am unprepared. This is not very nice of me, but this is what you get. What are we interfacing with? Micro, okay. Did I not have something? Oh, okay. I think it's potentially this guy. Let's see. Oh, there we go. Okay. So, it's live. We have power. Ideally, you don't want to run this too much through just the USB. I guess it's fine. You just don't want to do a lot of servo movements. I don't know how many volts come through. I'm not an electrical engineer at all, but I do find these embedded circuit type stuff fascinating nonetheless. So let's open up Arduino here. Let's also open up a web browser and get that stuff shown up on the stream. Robot arm Wi-Fi. Okay, so let's add this as a source. I'm adding the Arduino IDE as a source. Let's see. Window capture, add source, new source. Okay. Cool. All right, so we have that. Can I increase this? Oh, I can. Very nice. Very nice. Very nice indeed. All right, so if we run the guy, it's already running, but instead we need to open up our serial monitor. Right? Yes. Serial monitor. Okay. And that additionally needs to be a new window so you guys can see. Add source. New source. Serial monitor. COM4. Done. Cool. So that's gonna be our output. We can just spit it right here, but we'll put that below these guys. Oh, but above Arduino. No. Yes. Here. Cool. So if we go ahead and run this guy, hopefully we can see something on the outputs here. Let's give it a moment to compile and spin up. Okay, as we do that, we can go over the code a little bit. So let's see how this is coming through. Okay, cool, we can see things. It's looking not terrible. So a few things. We need to be a web server. We also need to be a Wi-Fi client. So the first order of business is to be an access point. We want our phone to be able to connect to this guy. The second order of business is once we are connected, we want to have the ESP32 deliver a web page at a certain URL. But I'm saying the gateway is itself, so you can, whatever you enter, it doesn't matter what domain or URL you try to enter, it's always going to come back to the server, because this does one thing only, and I just want it to deliver a web page to some phone. All right, so we have an access point. We're delivering a web page. Once the web page loads, I have some code written. Oh my goodness, I need to figure out where I saved all this. But here is essentially the page I'm delivering, which is some HTML, and then we get over to some JavaScript, which is simply connecting back to the host with a WebSocket, and I'm establishing a WebSocket connection. Now, when the WebSocket is established, I'm then talking back and forth with a JSON. So we can see the information being logged here. Let me connect to this on my phone. So I need to change my Wi-Fi on my phone. That's what I'm doing here. Can we see it? Here. So I have it named Control Me Daddy. And the password is Hello My Son. So I don't know if we can see it here. Yeah. Okay. Balance is probably terrible. If I open up a new tab here and just type in like literally anything, a.com, and send it, it pulls up. Here, maybe it looks better on this phone. No, they're both equally terrible. Okay, yeah. So I can now control one of these sliders. Wait for it. Yes. And as I move it, it moves the arm. Alright, how cool is that? And you can see the numeric value being sent, as well as the current JSON. So I'm sending a Y. This is sending an X. And there you go. That's it. So we're just gonna continue development on this. What's up, Kyle? Welcome to the stream. Cool. So we're gonna leave that open. It's been a while since I've actually done something here, so I need to kind of refresh my memory. So yeah, let's look at the code and see where we're at. I think one of the ideas I had was to standardize the input a little bit, and by that I mean like from a web page, when it talks back to the ESP32, right now it's just sending a small JSON, which is comprised of a letter as the property, and then the value is a number from 0 to 180. I'm kind of thinking, because this is for my friend, so for him to consume this, he can build an application around this. I want to ultimately, I think I want to standardize and say, okay, every string you send, I want it to be X, Y, and Z. So that way you can control multiple things at once, and we can intake all of those values at the same time. maybe. Or simply, because I think I had a comment, it was like, yeah, need multiple of these. So this is the servo instance. So because we're going to be controlling multiple servos, we'll need at least 3 of these guys, and then we'll need to pull in a DC motor library, which I could pull from a previous project. Interesting. How do we want to do this? So in the log here, let's see. Get text. That's the thing. I need to figure out. First off, I need to open up VS Code. Okay, so I have VS Code open. I could share that as well. How do I need like a codecs thing to like switch back and forth between windows. That'd be nice. Hotkey this thing. But we'll just have to manually switch in between things for now, which is, I guess is fine. Window capture. Yeah. Create a new window here. Call it VS Code. Add source. Interesting. I'm not seeing VS Code as a window option. COM4. Oh, maybe it's this? Nope. Maybe set a home function or make a few buttons on the web page to set highly used positions. So, yeah, that reminds me. Thank you for that. Set highly used position. So ultimately, I want the user to have full control of this arm. So I need to, as soon as you start it up, we need to write an initialization function to calibrate. Essentially, it should default automatically, but you never know. So we need to play around with that. Make sure we are, say like the web page delivers the buttons, at 90 or whatever it is, 50%, or it's right in the middle, 50% to the left, 50% to the right, or right in the middle. We don't really know where the servo may be mapped to, so we need to extend all the way both ways and get those values and then land in the middle for everything essentially. Maybe we'll keep that on the back burner. As far as like a home function, yeah, that's a good idea, to be able to like press home and then have it return back to the 0, like 0 0 everywhere. Let me add this VS Code as a source. I'm struggling trying to find it. Oh, there it is. Okay, cool, sweet. It's huge. I still want you to be able to see it. Okay, cool. That works. So, yeah, real simple. We have 3 inputs here. And then each time you change any of the movements, this function is being called, which is this guy right here. So we're sending whatever the value is of the slider, along with a string, whatever. In this case, it's XYZ, and that is going to be our particular axis in which we're going to ultimately understand on the ESP32 module and then translate that to that specific servo instance. So there's a lot to there's a lot going on here. Okay, cool. So let's get some to-dos going, because I seem to work best when there's to-dos. That music is a little loud. update the to-do thing on the stream. I think it's subtitle is the name. Okay, so to-do. First thing, we need to, I think, I don't know if I want to straight up plug in the other 3 servos and get those working based off of like certain input. I guess that would be a good idea. Make the other servo instances and create some sort of parsing logic to update that specific servo. So let's do this. Before we create a JSON that has like all of the properties in one like packet that's being sent each time, what if we keep it small? And then this is just to get this out the door because I've spent way too long on it. I'm thinking just keep the packet small and just simply do like an if. Just if it's an X, do something. If it's Y, do something. Because I've been struggling a little bit with trying to understand how this JSON library works. Alright, I'm going to turn off the VS Code. Cool. Yeah, so if I come back to the code here, I'm pulling in this, I don't even know where it's at. Yeah, Arduino JSON. This low level stuff is a little bit difficult to work with, in my opinion. I'm sure once you start working with it for a little bit, you're good to go. But I don't typically play around in this low level environment, so it's all a little bit new. But I realized, where are we at? We need to JSON parse. Right. So ServoState, I believe, is something I did not create up above. Or maybe it's just not being highlighted. I try to find this. ServoStates. Oh, I did. Okay. So, oh my goodness. All right. Because each property, when we serialize this JSON and essentially assign it to memory addresses on the Pi, we'll be able to then reference those memory addresses and hopefully be able to access them. I think it's like a dictionary or something is how they have it set up. Let me barf out all of the bookmarks I had on a browser. We can look at it. We can explore a bit. Okay, let me share this window. This guy. Cool. So we'll move him up above. Cool. Let's expand that a little bit. Okay. We're just gonna go explore, look at some internet stuff. Right. So programming Arduino this. All right, you ready for this? This is a pretty cool feature of Chrome. Right click, open everything. Are you sure you want to open all 26 tabs? I'm ready for it. Let's do it. Woo! Sheesh! Ugh. I am always scatterbrained. It is incredibly difficult to follow along, even for myself, so God bless you guys trying to follow along. Essentially, like, I just start looking into things and try to find like helpful tabs, and if I'm gonna need it in the future, or I don't need it yet, but I'm gonna need it soon, it persists. Okay. Right, so there's gonna be a lot of like web browsing just to learn some of this stuff, but there is some documentation about this JSON thing. What was I doing over here? This is like the core ESP32 docs or something. Okay, here we go. Deserialized JSON. Oh my goodness, just look at all this. just nonsense. Like it's so much easier in higher level languages because like straight up you just do JSON parse and you're done. You start playing with your data. Whew, it's getting hot in here. So, right, if I remember correctly, JSON parse, we're gonna need to take our string, so it's gonna be coming in as some sort of an array. Oh my gosh, I understand why people have hotkeys now. It's so they can like switch between what windows are open. So if we take a look at this code, go back down to the ServoStates here. Right. So whenever we get text in, so WebSocket event. You gotta like recall what's happening here. So whenever we're connected, it prints. Whenever we get data, this is our main case statement here that we'll be using. So whenever the server gets a response, it comes in as something. What are we printing here? Num. What is num? I think this means like an like what kind of data type is that? uint8t. Oh my gosh. And then this thing here, this is a pointer? Like what even is this? Unsigned integer pointer, I guess? What's our payload? I forgot everything about this. And I need to cast it to a character. It's an array. I need to cast it to like a character array or something. Is that what I'm doing? Because I'm passing a pointer here to JSON parse. What am I calling JSON parse? Oh, that's down below. Okay. JSON parse, right. So I was creating some, I was creating some helper functions to make this easier for me to work with. That's what it was. So test is parsing succeeds. What is my serialized event? What is the last thing I sent? Are we printing anything here? I just have errors. So literally I could be sending things, I don't even know if it's working. Deserialize JSON. If we get an error, I know it's showing up here, but if we don't, then what? So we've deserialized. But what does deserializing do again? Well, that's a great question. Glad you asked. Let's find out. Deserialize. The function deserialize parses a JSON input, which is what we're sending. This is going to be receiving a JSON input. And puts the results in a JSON document. If I knew what a JSON document was, we'd be solid. Alright, let's look at these signatures. Or let's look at... They just have examples? How do you view the JSON input? When you pass a stream... Okay, am I passing a stream? Interesting. Here's some examples. So, okay, here we go. Oh, okay, so we pass a stream in as the first object. No, okay, let's go look at the signatures. It accepts 2 arguments or parameters. No, you send with functions, you send argument. Okay, same thing. So the first thing is of type JSON doc, but it's an and. What does the and mean? I don't know. This is a lot. And then it also accepts a character array pointer. So if we pass our pointer, let's see, what are we accepting in our code here? Doc. Okay, but what are we calling it with? JSON parse ServoState. Just straight up servo. What is this? Oh, okay, this is where we're going to be storing it. I see. Okay, this is that global thing we defined up above. So this is our JSON doc. Okay, so we'll be storing the parsed JSON here. Should I just do it an easier way, where I just straight up read the string that's coming in, and then just find that first character, throw it through like a switch statement, do something? It sounds so much easier. And we could actually get that like rolling. I know the right way is to do JSON. But do we care? Do we actually care? So my thought was we could send the JSON as a whole. It comes into our ESP32 module. It then gets stored into memory. Then, for each servo, we then go through and update it. The reason for this is because what I'm thinking is if we send it in just individual small packets, we may be losing data. Because if say we send like X coordinate of 75, cool. We read that, we then go and move the servo to 75. The whole time I could be getting more crap coming in. I don't know if there's an interrupt or how this works. I guess we could test it and find out. That would probably be the best thing. So let's do that. Let's try to grab our character and match that character in a switch statement. And then the value we'll send to a servo instance. Okay, so as we have a servo, alright, so my servo, where is my servo being used? Start WebSocket. Okay, my servo attached. Oh, I've disconnected. Do you see that in serial monitor? What did I disconnect? Oh, it's because okay. Let me refresh the browser here. Okay. Let me adjust the balance on this camera. Okay, that looks a little bit more human, not such a ghost. Oh, goodness. Alright, so to do. Did I close out of that? I think I did. First thing, we're just going to grab the individual character. That's the first goal. Second goal, we're going to create different instances of servos. Okay, we got this. Our goal tonight is to move all three arms via the three inputs. That's what we'll do. We do that, and then we keep that like super fundamental, right? We get an input, we move the servo. That's it. Then we can build on top of that and say, when we initialize, we move crap. Then we can move over to the better language, JavaScript, and actually write some useful code and just interface directly. See, that's the thing. That's the thing. If we were to interface directly with the ESP32 module from our browser, say that home function, right? We want to recenter everything. What that could do is individually send X, Y, and Z as separate packets. Then the Arduino should it's going to drop packets. I know it is. It's going to miss it because it's going to be busy moving the servo, and it's going to miss the other WebSocket packets. So that's kind of where the idea behind sending everything as one JSON and then breaking it down and like parsing it for each servo. That way, if you hit a home button, you can send one JSON object. It has all the values. You won't miss anything. That's more difficult. But that's where my mindset was previously. That's what it was. Okay, so our goal is to, I guess we're going to play with this JSON, Arduino JSON thing. That's our goal tonight. If we can destruct it and get some like workable data out of this, maybe we can move all three arms. So we'll keep that as like a to-do. Move all three arms. But before that, I mean, we haven't even utilized the JSON library yet. We're just getting a string. Deserialize? Is that what? Deserialize JSON. Now, I want to be able to then read from JSON stream. Well, I'm just going to say object. I think that's essentially what it should be. Done. Okay. So we want to deserialize the JSON, read from the JSON object, and then at that point we can work on moving all three arms because we should be able to get that data. Okay. So from the front end, I want to be sending eventually a more complex JSON that contains all three states, if not more, and we should be able to then I think once if we structure this correct, we should be then able to more easily use this stream of data and do more complex things. Like maybe I could, how do I want to do that? How do I want to move the DC motor? Because the DC motor is an on-off thing, right? The DC motor is an on-off thing. So in a world of sending positional packets, how do we translate that to time segments? What do I mean by this? Like, if we want to hold a button down on the browser, that should correlate with the pincher arms, whatever, continuously moving. But that's just that's one event happening on the front end, the button press, right? I could continuously send, like saying button down, whatever, you know, close, like the arm position could be, we could send like, I don't know, open, close, or just nothing, null or something like that. But I can just continuously send like close. So each time we parse that, we can move it just a little bit. I don't know. We'll have to think about this. Because from a usability standpoint, you just want to be able to press and hold the button and then have the thing move. Additionally, we could make a button to where you press it and then it moves the pincher arm just a little bit. Like maybe, I don't know, 5 millimeters per button press, and you just continuously like, oh, that's not enough, press it again. Oh, that's not enough, press it again. I don't like that though. So any ideas on that would be welcome. But for now, we're just going to try to deserialize the JSON and move the arms with it. We've gotten most of the functionality working. Like we can send. We're sending an X coordinate. We're moving the arm. We're physically moving the arm. So that's pretty neat. And I can send the Y. So I'm just mapping everything to the same servo at the moment. But as you can see here in this monitor, you can see Y. Make sure. I need to plug in auxiliary power. It's heating up. I'm trying to run all this stuff off of USB. that's less than ideal. Okay, so I just plugged in AC power, so now I'm not driving servos off of the actual ESP32 module itself, but rather it has its own individual power, which is much better. How was that working before, actually? Yeah, okay, cool. We solid. So let's see here. If we deserialize, what's our examples to read? So we were working with that in our IDE. JSON, okay, so we're sending our string. This is our JSON. See, this is our character array, which we have. We should have a character array. Oh, we're just looking at the... How can I show the window on the stream in a usable format, but also the code? We'll just keep the code open. And I'll just try to relate what I'm seeing on the browser to this. I don't know. There's just there's too many windows to look at all the time. I already got 2 cameras. I got 1 monitor. Could probably use another one, but there's just not enough room on the stream to figure out all this stuff out. I guess I could. What if I do this? So at the top, we want the cameras, but also we could move this camera up so we could see both things. Okay. Now I could have our Chrome window in the bottom right. We can show the serial monitor somewhere else. How does that show? That's a lot of information. I think it's okay. Then I could have the serial monitor kind of peeping out just a little bit, so you can see the data coming through there. It shouldn't be overly complex. Actually, I can shrink it just a little bit. Oh, here we go. Yes, this is good. Okay, so you can see the code, you can see the serial monitor, and you can see the browser. Oh man, what more do you want? Like, honestly, what more do you want? Wow, 40 minutes, we've done nothing. We're thinking. That's what engineering's about, right? We're designing things. God bless the people that actually make this stuff. Okay, so here we have a character array, and we additionally have a character array with a pointer. I should say a pointer. So we're pointing to a string array. Let's put it that way, a string array. Okay. So we've created read only. Hopefully we can just continuously overwrite the stream. So we have doc here, passing in doc here. I can actually blow this up a little bit. Okay, there we go. So we've created this doc inside of our code. We call it ServoStates. So we want to play around with ServoStates down here. So once we're inside of, once we've deserialized it, I mean, I don't think we're getting an error. F. The hell does that do? Some of this code, not gonna lie, I copied and pasted. Because it can get so low level. I just want to be able to crank this stuff out, you know what I mean? Know what I mean? So, okay, well, what if we just, what if we do this? It's called ServoStates, right? So let's do something like this, where we have X. So if we send, actually, you know what? Our Controller's gonna break for a moment, but that's okay. That's okay. Can we get also... Oh my gosh. Look at all this. An array of an array of an array. So now we can access it like that. How do we know what all properties we have? How do we know that? There's got to be like a get. My mind's thinking, okay, if we send 3 properties, X, Y, and Z, I guess in the documentation we'll just say you have to send X, Y, and Z because that's what I'm looking for. If you don't send it, that's on you. That works. So we'll just keep it hard-coded again for the sake of just cranking this out. So we'll call this just state. Wow, did I already change that? I am just, alright. ServoStates, I believe is what we called it, right? ServoStates somewhere? ServoStates. Let's just copy paste, make sure it didn't have a typo. Okay, so now we have state, which should be a number. In this case, they're over here, it's a string called world, but we, first off, yeah, okay, our JSON should be there. So state should be, let's print a new line, because our state should be the number. How do we print? It's a character. It's a S. We want to print F, stringified object. Are we printing that anywhere? Stringified object. Sounds terrible. JSON stringify. Passing in the doc. Am I calling this anywhere? Oh man. Sheesh. I think that was just a to-do thing. Jeez. Why do I want to stringify? Stringified object. Is that for debugging purposes? Possibly. But we can print a character here, JSON string, because that's one character, whereas this is a character pointer. So how do we print a character pointer in Arduino? Yeah, what is this again? Unsigned. That's an unsigned character pointer? Unsigned character pointer. How in the world is uint8? Oh my goodness. That doesn't even make sense. Okay, so Arduino print pointer. I don't want to print the address, I want to print the value. So if we Arduino print, I don't know. So if we have a pointer to something, how do we get the value of a memory address? Print value of memory of print value of pointer. You can store the pointer address in a variable and print that out. If you want to print the value of a pointer without using the specifier, oh, well, that's convenient to know. Let's grab this guy, and then if it says %p, where our pointer is now state, and we could say, let's just be like debug value. That's all I want to know. Is it there? All right, let's upload. Let's see what I messed up compiling. Oh. All right. Well, let's see. How do I want to do this? I'm thinking about whipping out another laptop. Let's see. Pretty sure I just disconnected from. Yeah. Oh, that's really annoying. So every time this happens, every time I restart or re-upload code, I need to update or log back in to the access point on the ESP32, which is annoying. DNS started. Come on. Okay, now if I send data, what happens? Debug value. Oh, that's straight up the memory address. I don't want to do that. Print. What is that type? That's mainly what I want to know. What is the type char? This guy. That's a character pointer, right? Arduino data types. Let's do that. Char. All right. Let's see if I'm just like wrong. Okay. Maybe we can just print it, just straight up print it out. Print. You can pass flash memory based strings and wrap them in F. Is that what I'm doing somewhere else? Where was that? This guy? Flash memory based strings. Flash memory based strings. What is a flash memory based string? Oh man. Okay. Print. They're saying the type. Let's see how we can print a character array. They're just saying print C. Try this. It works with char, but not with unsigned char. Okay, so what's the difference between char and this guy? It won't compile. What is it? Oh my gosh! Come on, people. Serial write. So can we just try printing? Let's just check out Arduino print. I guess, is it serial print? Is that what we're doing here? Serial print, yeah. Let's just, okay, well, I want better examples. Or, no, I want other people's examples. Print array, okay, maybe. Serial print, new line, serial. Oh. Can we just do this? That's cool. Is there a way to print an array using serial print? Ugh. So for size of my array, it shouldn't just be 1. My array is state. Oh, we're just printing. Let's just try to print, like, straight up. But I want to print like a string with it too. You know what I mean? I guess that's the only thing it doesn't have. A character eval, char eval. I want like a nicely formatted print so I can add some text. What am I doing above? Probably just screaming at me. He's like, just do this, damn it. Or would you just print something before it? I guess that works too. And then just print the value below. It's not what I want to do, but it's what we will do. And I'm just gonna straight up print state. Debug value. My god, why did it just turn red? That's horrific. Okay, now it's gonna drop the internet. That's going to be atrociously annoying. So for the time being, I'm just going to forget my home networks. Cool. Where's our debug thing? Debug value 99. Oh yeah? Oh wait, okay. Oh, so it worked. Debug value 112. Perfect. Awesome. So now so we're going to disable the move servo thing. Where are we moving our servo? I want to send a more complex. Oh my goodness. Let's get a formatter. I need to compare differences between what I have here inside of this string, shift end. I'm gonna throw it in a pretty thing. HTML pretty print. Wow. Wow. Oh my god. Make pretty. Make it pretty. What? Unexpected character. Oh, the quotes. You're so right. Because for all the strings, I had to put back quotes. Is that right? Yeah, for every string. For every backslash string, I need to undo that. So, all right, Control Tab. Oh, no, new. Oh no, Control Shift T. I don't want to lose this guy. He's important. This guy's important. Oh, I also have them on Git, so that's cool. So if we control new, there we are, and we paste, and then we control F, wait for it. Here we go. We're going to find backslash this guy, and we're going to replace it with just that guy. Replace for everything. Now, we're going to copy everything and throw it back into this guy. Bam! Now it works. Make pretty. I want it prettier than that. I want this prettier. I want it prettier. Can we... What's happening? Why? Like, why can you not format correctly? Is that where I was just at? No. Format HTML. Maybe? That'll work? How come we can't just, like... There's like a code beautify. Beautify it. Oh, okay, that looks beautiful. So I wanted to find a difference. I don't know what changed. I think I made some edits. Basically, there's the missynchronization between what the Arduino code actually is and what the HTML file is. I'm trying to resynchronize that. Although, what you can't see is me playing in VS Code, which is where I'm at. Here we go. Okay. Right. So, basically, I've taken the code from the Arduino IDE. I believe I made changes to that, and I need to translate these changes back into like this working HTML so we can continue to develop that more. But like, why is it so atrocious? One moment as I find some sort of pretty fire that I'm content with. Looks terrible, but it formatted my HTML, so let's see what happens. Disgusting. I'm gonna highlight and format. Okay, so now we have the latest changes, which are in the Arduino here. Cool. I guess I could have done that to begin with. Come on, Garrett. You're tired. Okay. So right, let's try to send a more complex JSON every time. Yeah? So we will set to console. Are we overwriting it anywhere? Yeah, we are. Okay. So it compiles. I'm gonna need to open up a browser for this to like actually verify it runs. Can I just do that in a new... I guess I can just open this up, yeah? If I just like save this and then right click, wait for it, copy path. Come here to the browser. What can we see on what's on the stream? Okay. I am in VS Code right now, but I'm coming back to the browser here. Paste that. Cool. If we open this guy up, okay, failed to connect to WebSocket, that's fine. Additionally, we could come here and try to like make the input a little bit better. I don't know how to style this input thing. This is height. I don't know, like 40 pixels. Does that do anything? Oh, no. Yeah, I have no idea how to style a slider. Okay. Irregardless. Let's go back to VS Code. And let's create an object. We're going to call it positions. And it's just going to be an object, right? It's going to have X, I'm stupid, X 90, Y 90, Z 90. Okay. Now, every time we change an axis, instead of creating a new object, we'll use positions. And we will update the axis with that correct one. We know it's 1 for 1. We could use typing here to verify that, but so we've updated our position with V. I tried to keep the code small here. I probably should like rename this stuff to like I'm trying to write like minified code, you know. I could run it through a minifier, and I probably should run it through a JavaScript minifier and see what it spits out, because that's ultimately what I want to do inside of the ESP32, is because I want the code to be like as small as possible, because we do have a little bit of limited memory that we're dealing with. Alright, cool. So let's see what this is doing. When we change the arm, we're going to update whatever position was changed here with the letter. So this would be Y, we're adding Y here, but now, so we need to remove this guy, and then additionally, we are going to be sending position as our JSON. So let's do that. Initializing should be set to 90 as well. And my value of 90, okay. So I guess I could go through and do I could keep them like in sync here, but I could additionally like pull the initial value. Oh, how do I want to do that? Go through and set if all these have, so they do have IDs. I'm thinking like I could pull the value or set the value. Let's have an init. There's connect. So when we connect, okay, let's create a function called init. This is going to be like the first thing that takes place, and I want to document.get element by ID, and it's going to be arm-x. Okay. So we're gonna. Oh my goodness, that's not what I wanted to do. Can you like? How do you? My goodness, that's not cool. Did I just mess up my? All right, we're still good. Okay, so let's just duplicate that a few times. X, Y, Z, and then X, Y. I don't like doing it like this, but it's not gonna be bad. Or we could get the element. Once we have the element, we have the reference, and we can do the value. We'd set the value directly. Ooh, let's do that. So dot value is what we should have here. And if we set that equal to position dot x, that way we keep it kind of minimize x, y, and z here. So we no longer even have to have these as stored values, because we're just getting the element directly and then assigning the value to whatever our initial positions are here. And this is going to be called once. Inside of here. So before we do anything, we want to yeah. Okay. Now let's refresh our page and see if we get any errors. Okay. And if we change like this guy to like 40 or something, and then refresh. Cool. So it is properly setting the initial state, which is cool. All right. So now we're sending, or we'll have the ability to send we have the ability, so we're going to be sending like the entire JSON now. Okay, that's fine. Moreover, I need to take this code now and like minify it. Let me, how do we do this? Is it tab? Alt tab? No. Shift tab. Shift tab, no. Control tab, yeah. All right, let's see if I have a minifier somewhere already. Minifier, perfect. Okay, so we're gonna grab everything we have, copy, we're gonna throw it into the minifier. It's behind the scenes, I'm just minifying it. No big deal. I'm gonna minify. Okay, I'm copying the minified code. So we're gonna come over here. Yeah, we can delete that. Actually, we'll just cancel. Select everything, and this is our minified code now. So we're gonna control find everything that is a backslash, and we want to replace it with a we want to find everything that is a single quote and replace it with a backslash quote. Replace all. Okay. That should have, yeah. I think that replaced everything. Let me just verify. Okay, we need to find like backslashes. Quotes. Oh, we have single quotes. Are we all single quotes now? Maybe it'll work. Let's try it. Let's see what happens. Right here, shift end and paste. Here it goes. All right, let's see what complains. At this point, if it loads, it looks like it compiled. Okay. Let me switch back to VS Code, or turn VS Code off. Okay, so we're compiling our latest HTML changes, so we'll reflect that inside of the phone, and at that point we should then be able to see what type of different values we get. Error. Oh no, that's not good. What is this? Error opening serial port 4. Why is that? Can we ignore that error? What? What happened? What? Do it again. Compile's fine. Okay. See a blue light. Maybe we just need to restart the serial thing. There we go. Alright. That was weird. Let my phone connect. Maybe. Come on. I was using, right now, this front face camera is an iPhone 6, and that's what I was primarily using for development purposes, but so be it. Oh man, come on. Okay, so now, if we just update this position. Oof. Ooh, we're not getting anything, are we? Client request. But we are not client oh, okay. Something's wrong. Yeah, something's wrong. Something's wrong. What's up here? What's going on? We got single quotes. I don't think the single quotes are happy. Don't think the single quotes are happy. So we're gonna find a quote and we're gonna replace it with a double. Okay. So we're gonna copy all that. We're gonna minify it again. Grab our minified code. Come through here, barf it out. Control find, find and replace, backslashes, dope. Grab it all, copy. Now we're done here. It's a lot. Hopefully we don't have to do this too much. Alright, so end and paste. Alright, let's see what's good. Maybe this time it'll work. I'm gonna go get more water, be right back. Okay. So we're connected, so if I refresh, nothing. Come on. Why are we on LTE? What's going on? I don't want LTE. I want the phone is smart, so it's trying to provide service all the time. I don't want it to do that. I want it to always connect to this access point. Okay. I'm getting the client request, but we are not sending. Is the page, is something breaking on the page? Let me verify. Ooh, something is broken. There's red. I think the page is breaking. Ooh. Yeah, that's not good. So I think what the issue is, so we do need single quotes here. Should be fine. Okay, if we put single quotes strictly in the HTML, I don't see why that's an issue. So if we move something, oh goodness, that is... Okay, it's fine. Just because it couldn't connect. But if we set a breakpoint here and adjust that. Oh, it's okay, so that's also interesting. We need to take the string value. So if we take positions and stringify it. So it's JSON, isn't it? JSON. Yeah, stringify positions. It doesn't matter. Okay. Sweet. So let's take this one more time. Okay, shift home. Oh. Let's try this. Man, we're just messing with HTML and stuff. We're not even like actually programming a thing. But I know what we can do while it's doing the thing. We need to essentially disable the current way the arm is moving now. That seems better. The arm's moving now. As before it was not. So what's the monitor saying? If I request a new page and send nothing. What's happening? Why is the page not working? Oh, that's annoying. Okay, what I'm gonna have to do is I'm gonna have to get my laptop. I'm gonna have to do this. Man, I got so many devices. This is ridiculous. I have another laptop, and I'm going to connect it directly to that access point. I'm going to forget the other ones. It's running Linux, but it'll allow me to inspect the web page and figure out where try to figure out where the issue's at. If it's dealing with the code coming back from the module, and we're having a problem connecting back to the host, or if the issue somewhere else. And debugging, that's part of it. Okay. Unfortunately, I can't show this screen, not due to like privacy issues, just because it's on another computer. I mean, I could, but I don't have that infrastructure set up right now. Okay, so let's connect to that guy. Select network. How do we forget? You right click on this guy. Wi-Fi settings. Okay. I want to forget previously connected guys. Connect automatically. Apply. Or moreover, we could connect automatically, just forget it at the moment. Yeah, I like that. Apply. I'm disabling my actual Wi-Fi, so it only finds the control me data, the ESP32. Okay, let's see what's going on. Open up the developer tools. We do have an error. Unexpected token function. Did I misspell function somewhere? Did I initialize it incorrectly? Highly possible. Oh, you know why? It's because I forgot semicolon. Ugh. Goodness me. That's it. That's all it was. All right, let's try that. That's ridiculous. So now we got that up and running, we can just leave it. Okay. What can you guys see? Arduino. Cool. So where's my servo write? Okay. We're just straight up saying grab, convert to int, my payload. We're just grabbing something, okay, which is not what we need to do. Because now we could it's a character. So we're converting to int. Unsigned. We'll need to take how do we know what values they are coming from the JSON? Does it do that automatically? Is it smart enough to infer types? Or does it just when you access everything, does it just come back as a string? These are questions that will have to be answered relatively soon, like now. All right, let's see if this thing just works. Let's see if we're getting that full JSON. Yes. Here's our text. So everything is coming in. That didn't do it right. All right, crap. So it's still sending, as you can see, this is sending a number, this is sending a string. Let's fix that real quick. Back to VS Code. It's sending a string. This is a string. We could... Do we want to send a string? Where were we sending before? Why is it a string? Is it always a string? Because we're setting the value as a... Setting the... That might be okay. We just need to potentially... Ooh. So is our debug thing printing? Oh, it's printing 57. So it does work as a string. But everything else needs to be initialized as a string as well. Now what happens... Oh, I don't like what I'm about to do. But we may have to do it. So we have numbers here, but we're setting the value as a number. And we're getting that back. But why is a string coming back? When we... What if we keep it always as a number? Is that going to mess anything up? Okay, without doing all this crap, I'm just going to go put a plus in HTML. This guy here. So if we put a plus in front of it, it's going to take it as a string and then add nothing essentially, but convert it to a number, and we'll see if that works. Sheesh. Oh man, this is a lot of work for no progress. But we're laying the foundation to be able to like actually start doing something. We just gotta push through it. We need to know if sending numbers still allows our serialized JSON function to work. Okay, let's refresh. Okay, we're connected. If we send some data, I don't think that worked. 68 debug value. Yeah, it does not know what a number is, so we're going to send it as... That's not good. What? So we sent it as a number, and it did not understand it. Why doesn't it understand a number? Convert... But it does understand... How do we know what's a string and what's a number? So if we're... What do we want to play with? That's ultimately what it comes down to. Probably numbers, right? Does the JSON thing accept numbers? Goodness, you'd think it would. Yeah. A pass int 42 inside of an array. So if user Toto, come on, send numbers. I mean, could we could work. Can we? All right, let's do Arduino string comparison, or just string 1 equals string 2. Character comparison, character array. Ooh, here we go. Char array compare. Yikes. Can we do this in an if? What is this guy? String comp. Oh, sweet. Oh, we can just straight up say this. Well, that works. Without, you are actually looking at a pointer. Yes, to the first element, correct. You can write a function that then iterates through it, correct? Okay, so We could just keep it as characters. Because, alright, so if we go back, let's test something. If we go back and we remove that plus we added in front of the V, so we keep it as a string, we'll have to go back and initialize everything as a string inside the our client code, which is fine. Alright, but now if we come back to this like serialize or this JSON parse thing, because this is state and this is a pointer to the first element, can we additionally do this? Now that would verify that this is grabbing a value or it's being returned as an array of just characters, therefore meaning it just doesn't know, doesn't care. Let's fire away. Let's find out. Okay, so we can compare strings. We'll keep that open. Right, let's go back to that JSON documentation. So I like this thing, but let's... What are we doing here? Are we parsing anything? JSON stringify. Why was I JSON stringifying? Oh, I think... Okay, so it reset. I think, my idea behind this was to kind of relay the current position so that the client can sync up with the actual positioning of the arm. I think that's overkill. That's taking it and pushing it too far. Especially at this point where we're just trying to get it to work. So if we send a value, cool. We should be able to... Oh, disconnected. Why did it disconnect? Did it crash? Did we crash it? Did we overflow something? Oh, debug value 9. Did we crash it? Ah! Okay, I reset it. I think we crashed it, which isn't good. Connection failed. Come on, no. DNS server says it started. This is just a pain. Okay. 7. Oh. Okay. No, that confirms our theory. Okay. Yeah, that confirms it. Because we were printing out the first element inside of the array instead of just the pointer to the whole thing, which is what this guy does. So let's recompile this and upload it. Okay. Cool. But so what that means is that it's returning an array of some type. We may not know what that type is. We need to... So we're deserializing the JSON. Are there specific types of our JSON coming in that are limited? So we're passing in strings here. What if we pass a number in? Can be configured with the following settings. Maybe we have to send just strings. which I'm totally fine doing. We can convert strings to ints. Question though, can we set a element value with a string? Because we may need to do a little nonsense on the front end just to initialize those values. Come on, just... I don't understand what the problem is. Computer, if you see an access point, just connect to it. It is just not liking anything. This is frustrating. And now we're here, and now it works. Okay, but I'm gonna inspect it, grab element reference, and let's see, $0 dot value, not validation, value is equal to, I'm gonna do a string of 60. It works, okay. So we can actually initialize everything as a string, and consequently send strings back. Good deal, good to know. Okay. Doesn't matter for now, because anytime we send an input, we're gonna get back a string. Okay. So now for we could then parse. Here we go. You ready for this? Okay. I need to create, so we deserialized now, and let's see how responsive this is. Okay, so we've kept the same real-time responsiveness now, moving through a JSON, but we haven't actually changed the way we're deserializing the stuff. Because we're not actually moving the element, or my bad, we're not moving the arm based on the JSON value. We're still moving it the old way. So we need to convert that real quick. Because currently, convert to int, and I'm passing in a payload. And this is like a custom thing. I'm iterating over a string, finding the exact position and converting that to an integer, and that's just not going to fly. Instead, we have to pass in ServoStates. So if we were to copy this guy and then use ServoStates, what does that return? We could just pass in X and then use that, but we need to pass in a number. We need to pass in an integer to the servo. So what is character array to int? That's what we need. That is what we need right now. Convert char array to int. Here we go. Yep. Scan F. Ooh, it's very standard. And in my opinion. Oh wait. I didn't say Arduino. ATOI? What does that mean? Wait, what? The first form command, okay, of 4, okay, would generate a compiler error. String of arrays, chars too long, since you've not left room for the terminating 0 required for C. Better off using, just say it's an array, in which case you could simply do, okay, command, at command. We don't know. That's the thing. We don't know how many things we got. But what if we just say the whole pointer? I don't know what ATOI does. To convert a string to an integer. Post whole code. Oh. Works with... Oh, perfect. Perfect. Oh, sweet. So we can just... I think we can just convert our entire guy. So ServoState, and we're going to pass an X. And that's going to return a char array, at which point we're going to ATOI that guy. But we may need to... Well, let's just see what happens. May get a compiler error. In which case we'll just extract it out. Oh, no, seems to be working. Okay, so at this point we are now, if this is going to work, what that means is we are going to be reading off of the JSON data coming in, which is uber neat because we could just technically copy paste that line just 3 times, XYZ, and we're done. Okay, let's get a new page. And it works. Awesome. So now, so my servo, we need to change this name to, we'll call it ServoX. Is there a rename function in here? Okay, so let's ServoX. We're going to create X, Y, and Z. Okay, remove that comment. All right. Now, my ServoX, we need to find all the servos. Man, I do not like this IDE. Okay, so attach 15. So I need to now physically wire up different, the different arms and stuff to this controller. That's kind of exciting. Arm 15. So I think I can just walk it down. 14. There was a picture of something that actually shows the, for whatever reason, the crap doesn't map 1 for 1. Oh, here we go. Yeah, it doesn't map 1 for 1 with the stuff listed on the board for whatever reason. So like the crap printed shows D8. Right now I'm in D8, but it's GPIO 15. Oh, consequently, if we just walk it down, it goes 14 or 13. Where's 14? We just don't have 14. We just decided to skip that. 1, 3, what? Why is it over here? Why is the... Wow, that is just all sorts of whatever. And then where's, okay, 13. That's not confusing. This is so stupid. Moreover, where's 11? I feel like they're lying to me. Alright, so I'm going to plug in to, so we're at 15, I'm going to plug into 14 and 13, respectively, which is 5, and we want 13, 7. Oh, I don't like where that's sitting on the board. Can we do GPIO 2? That'd be a bit better. GPIO 2. That is pin. What are we looking at? D4. Gives me a little bit more room on the breadboard to plug stuff in physically. Ooh, I don't know what I just did. I saw a light come on. I should probably unplug this shit. That would be smart. Hold up. I'm over here. I'm alive. I'm plugging stuff in. Struggling. No doubt. Okay. So in no particular order. Well, actually, it might. It's not even like. I mean, we could just change the values around, but all three are now plugged in. Okay, so let's initialize those to what did I say? What am I in? I'm in 2. So servo, let's just say servo X is 15, and then I have moreover X, Y, and Z, and I plugged one into 14, and the other one is 2. Okay. Whoa, what is that? So my servo, if we go servo X, so then I'm just going to copy this, and we're going to positionally update things every time, X, Y, and Z, then X, Y, and Z. Okay, let's see if we now have all three axes up and running. We should. need to figure out a way to more conveniently wire this stuff up, because it is just very hodgepodge right now. Oh my god, no! Ah, what's happening? Oh man, that's real interesting. I need to make sure I wired this up correctly, because it could get very hot. I might actually fry the ESP unit if I'm not careful. So, oh, I need to refresh the page, reestablish the connection. Okay. We broke something. Something broke. Cut here for exception decoder. Oh, we indeed broke something. Debug value 84, exception. Oh, am I still trying to do other things? Okay, let's, yikes. So it restarted. Let's reconnect. Can we move another axis? Just one. Yes, but it's breaking violently. So we should also write some logic, and we should store to see if the value coming in is different from the value. Oh, but then we need to have potentially two different JSONs, because it would be nice to check to see if the value coming in has actually changed from the value that is currently set. We could internally just keep track of that. But we need to figure out why it's crashing. We need to figure out why it's crashing. Debug value. Oh, it's blank. We need to figure out why the debug value is blank. So if I refresh, Control Z axis this time. Scroll down to the bottom. Connection established. It's struggling. It's breaking. All right, this is no lie. I don't know why it's. Does it tell us why it's barfing? Cut here for exception. Oh, wonderful. Thank you for barfing out the entire stack. Yes, I know exactly what this means. Oh, exception 28. Maybe we can just Arduino JSON. Arduino JSON exception. What is it? 28. It looks like the program is passing null strings. Oh, are we trying to print? I mean, it should be fine, but let's just not print. Yeah. Let's just comment that out, yeah. If error. But if error, because we're getting error here. Deserialized JSON failed. It's trying to print this guy here, which we don't need to print this anymore, nor do we need to get state. Let's re-upload that. We're close. I need to keep an eye and make sure things are not overheating. The weight of the arm is making the thing like twitch because it's trying to keep that position. It's actually moved out of view. I need to put some like rubber pads or something on there. Okay, well, it's up and running. So let's connect our web page. Okay, we've connected. Let's move the x-axis. Oh, it still crashed. It just instantly died. But now, get text. What is the order of execution? Get text. Connected. Let's see. Maybe we're still passing it into something that's breaking, which is highly possible. Convert to int. Are we saying? Look at it like twitching. Is it showing up over here? No, not really. Oh my goodness. Oh, that servo is getting warm. Which guy is that? Arduino servo is twitching. Is caused by an inadequate servo power supply. Trying to use the connect the grounds. Power is indeed a common problem. Use the connected and power as required. Okay. Alright, we need to move fast. Before we start smelling electronics burning. That should be enough power. Maybe it's a dirty supply. I don't know. It should be. What voltage am I at? I'm on 5 volts. Oh, board's hot though. Doesn't smell yet. Okay. Null strings. Why is it still? It's still just abs. All right. Get text. Where is that happening? Get text. Here we are. So it's breaking here. Okay. Let's just not. Well, it's actually fine there because it printed that, but it's breaking in. Potentially it's breaking at the servo line. Let's print a new line. Updating servos. See what it gets to. It could be that the data coming in for whatever reason, I don't know if it can't fetch it or something. Potentially overwriting it each time is not good, but it should be okay. Okay, let's get a new web page. Ah! Holy shit. Well, things are happening. We need to, it keeps restarting, so I'm gonna have to keep refreshing. We're still barfing out. Cut here for exception decoder. Boot mode 3, tail, checksum. Updating servos. Right, okay. So it's getting here. Do we know which particular servo it's breaking at? Maybe this is incorrect. Maybe we could store these values temporarily and then pass them in. So if we break it up, because we're doing a few things here, but maybe we could fetch these values, see if we can fetch the values correctly, then we could roll out the JSON thing, and then maybe we're actually passing in this data into the servo incorrectly, which is possible. So let's just const char whatever this guy was down here. We'll just call it XYZ just to keep it simple. X, ServoState X. X gonna give it to you. X, Y, Y, Z. Z. Additionally, we're going to come out and print it as well. So let me grab that print from down here. This is state. We're printing state, so it works. I'm going to grab both of these. Where am I at? Here. So uncomment this. And then I think serial print is a thing, right? I hope serial print's a thing. Print new line. I just want to print here. Print with space. I just want to see what each value is getting. Okay. And then, additionally, now we no longer have to pass all this in. We could just pass in X, Y, and Z. But I want to extract this out a little bit more because I want to know what. All right, let's just see if it breaks here. So we should be able to print the values. So I'm thinking it's because this error is so well written. There is an error. I'm gonna say it's this package. Could be the print throwing it as well, but I'm gonna say it's a JSON. That is my hankering. Oh my gosh. So if I just move this, it's gonna fail. Oh my gosh, thing's gonna jump off the table. Okay, right. Yep, it's not getting Z. But the actual problem. Oh, because they're still. Oh, interesting. Because they're still coming in as. Oh, gotcha. I see what the problem is. Yep. So what do we hear inside of our code? It's fine. We need to come through here into the HTML and update the initial object to have strings. So at the beginning here, this guy, yeah. We need to have backslash these guys. Okay, that should do it. That should solve the bug. Now, everything should work. Well, moreover, we should get to our next problem. What a flex it must be to write like C-level code, just like barf it out with no issues. Man, it must be nice. You're always thinking like dealing with pointers and stuff. It takes forever to write just simple things. Like you can spit out legit full applications where, oh my god. I love the initialization. Okay. But you can spit out like full-blown applications with just higher up languages so quick. It's disgusting. A lot faster than this. Okay, we're moving values. Whoa. Whoa. It was moving multiple oh, you see that? I don't know. Can you guys see that? Let's see what you guys are seeing. Check this out. Oh, hey. Now, this guy down here, the Z axis, is not having it, is it? We are getting the value coming in. That is not being updated, but for whatever reason, when I move X, both of those servos are moving. That leads me to believe there's a typo somewhere. Did I see X, Y, Z? Oh, there was a typo somewhere. Okay, cool. Now we should have. We've done a lot. What do we do? We have deserialized the JSON. Where's our to-do? Oh no, where's our to-do? We want a to-do to be like, to-do. All right, yeah, so let's update that. We have deserialized the JSON, meaning we are ingesting a full JSON and we're storing it, and we can retrieve the values. Oh my god! This fucking initialization process is insane. Read from the JSON object. We're doing that. And we're moving all three arms. Let's just verify before we say done on that. We may be close to finishing for tonight. So let me refresh the page over here. So we're moving one axis. Check. Moving another axis. Check. Moving the Z-axis. Check. Oh, this guy's a twitchy boy. Disconnected? No, why did it disconnect? Did it break again? Is the thing broken? Why did it disconnect? What the fuck was that? Disconnect. Why does it keep disconnecting? We can move all 3 arms. I want to know why it's disconnecting. Moreover, now we can recenter. I don't like the speed at which these servos are moving. How can I adjust servo speeds? Arduino servo speed. I want to slow it down. So I can write a position, and it's just gonna fucking hightail it over there. Well, just increase the delay until you find it slow enough. Sometimes it can be jittery. What exactly didn't seem to work? How fast? So we may have to write a function to slowly loop to a position. This can be later, but we may have to write a function to slowly loop to a position so we can now then control the speed, because right now I'm just sending a position and the servo tries its hardest to snap directly to that position. So if I set a value, is there a get? If there's a get of the current position, that'd be awesome, but I may need to additionally store the previous value. That way, before I overwrite the JSON object, I can find a difference, and that way I can slowly iterate up to that new point at a delay of my choosing. I like that. Might have to do that. Maybe we could crank that out real quick. Maybe. Let's see if we can get the current positions from a servo. Get servo position. Servo read? No way. Servo read. We can. Hot, hot, hot. Fuck. They're very hot electronics over here. Let's let this cool down. Unplug that. That was the most sad thing I've ever seen in my life. Okay. That is very warm. That is very warm. That's okay. That's an issue. Ow! I think I burned myself. Why did it turn off in the most sad position ever? Additionally, this servo here is hot because it's constantly twitching. Which guy is that? I don't like this guy. He's always been twitching. What's the heat on the actual device? That's fine. Okay, so the heat on the actual ESP32 module is okay, but that power distribution thing, those I think are they? What do you call them? MOSFETs? Are they MOSFETs? I don't know. No, they're step downs. They're the fucking voltage regulators. Those voltage regulators are very hot. I touched it and I went ouchie. But also the servo is hot. Like it's warm because it's just sitting there twitching. It's constantly drawing power. I need to figure out why that particular servo is twitching. Moreover, we could just we could not. But why do activation of network connection failed? Why do I keep disconnecting? Oh, it's because I turned the thing off. Okay, what if we remove that? Troublesome servo. Yeah. Okay, so we've removed it. Now we're gonna let that cool down for a second. So, okay, read the current angle of the servo. The value passed to the left. All right, so let's write a servo move function. Moreover, let's look at the ServoWrite library and see what we have available. Write microseconds. Write a value in microseconds to the servo, controlling the shaft accordingly. Set the servo to mid. What? On a standard servo, this will set the angle of the shaft. On standard servos, the parameter value of 1000 is fully clockwise. Okay. Well, microseconds? Note that some manufacturers do not follow this standard very closely, so that servo often responds to values between 7. What? Why would I use write microseconds versus write? Servo write versus write microsecond. Other people are asking this very pressing question. Servo write allows a maximum of 180 servo positions, while write microseconds allows maximum of 1000. Why is it seconds? Is that how we measure positions of a servo? Seconds? Seconds are also like another way to say degree, I think. Okay, that makes sense. But we can, more importantly, we can read. Get the current angle of the servo. Perfect. The value passed to the last call with write. Okay, so we don't have to store anything now. We can make our own move function. We can make our own move function. Does it return a variable of type servo? Let's see examples of servo read. Does it return an integer? Do we know? We don't know. Okay, so let's do servo read data type. Does it not tell us? Oh, my finger still hurts. That was very warm. Let me feel it again. Okay, it has cooled down greatly. 11:30. I'll be right back. Okay. All right. Why did I want to create a speed controlled function? because it just tries its hardest to snap to a certain position. Servo, let's see if one just exists. Thank you, save me, reinvent that particular wheel. Right is used full speed. I don't want to have to import all that. I mean, we can just create our own. It's fine. Something simple. So we could make it default. So let's see here. So it's working, first and foremost. So that's neat. We can clean this up later. Let's see. Is this reflecting? Yeah. Okay. Oh. Oh no. How long has that been out? That's just scope creep, to be honest. That's what I'm thinking of. I'm like, yeah, we could... Okay, so I like the idea of being able to center the thing, but if I center it, it's going to try aggressively to get to the center as quick as possible. Maybe that's a time for something else, I think. Because I do like the home button to center it. You can like reset everything. Alright, let's play around with it a little bit more. Okay, so it should be up. It's connecting. Give it a second. So I've disabled this servo here just because it's hot. It runs weird. It twitches. I need to figure that out. But I just want to play around with the arms a little bit more to verify that that is working correctly. All right, so we're here. So x-axis. We're getting intermittent. It's disconnected again? Oh. I need to open up a new... Oh, did that just close out of this thing? Tools, serial monitor. Okay. Was good though. Client connected. Yeah, see, I think maybe its printing could be quite slow. Trying to figure out the lag here. Thing doesn't like jump off the table. And then so I do need to, I will read before I update each one. I'll read to see if the value has changed. If it has, then I'll call it. So maybe I could just do the same thing inside of like a move servo function, to where if it did move, I can give it a speed. Maybe I do need that function, because it may be trying to write the position. I don't know. I don't know if it's inefficient. Let me remove some of this logging. See what this does. Might make it a bit more efficient. And we need to figure out one of the servos is hot. Servo hot. Make sure the Arduino ground and power supply are connected together. Also make sure the servo is mechanically bound. If there's a servo that is prevented from reaching its target position mechanically, it keeps full power flowing through the motor, which can be a lot. A good servo will reduce power to prevent overheating. The servo, let's see. Before you write it off, take it aside and use the example. See if that shows. Interesting. Might be problematic. Okay. Let's reconnect. The DNS server has started. Right, how did I do the DNS thing? We just did the Pi-hole. Alright, so DNS, anything, I want it to go to this gateway address, which is... Or maybe I'm saying... DNS port. If you go anywhere, you're going to get this request. And the server IP is local. Yeah, I'm connecting right to it. Local IP. Gateway. Yeah, point it back, straight back to this guy. Cool. Okay. Come on. No. Is it still up? Okay. I'm seeing right now. I'm looking at. I have my phone here, and I'm changing the values. I'm checking to see if it's getting the values. Yeah. No. I want to know if it's getting the values and if it's updating as soon as it gets the values, or if there's a delay in the WebSocket thing. Okay, so right there it had a lag. I mean, eventually it caught back up, but I noticed I was transmitting data and it lags between getting the latest. See? Okay. So what I could do is implement kind of a heartbeat on the client side to just kind of say like this is my latest. So in case there is a bit of a hiccup somewhere, it'll eventually catch back up. Seems to be all right. What if I do both at the same time? That's what I'm talking about. Right. Look at that. It's working exactly how I wanted it to. So I can go over and grab something. I think sometimes the difference isn't big enough. It's interesting. It's like it'll get there eventually. Sometimes there's a... maybe there's a delay. Huh. Interesting. Oh, I can almost not see that. Most of that movement. Okay. Well, we can move all three arms. Let's feel how hot things are. Warm, not terrible. Warm though. Let me look over, see if we have any like delays or something. So there's delays at the start, but during the actual looping, process next request. How could we do that? How could we do that better? I want to take everything as quick as possible. On event, WebSocket event. We're just printing the payload. That's all we're doing. Just printing the payload. It seems to be writing whenever it gets the text. I think this is fine. But it seems like this guy here, sometimes the events are getting backed up. Now, why are the events getting backed up? Is it because one of these processes is too slow? I don't think we're doing this guy anymore. Can we control find? Find all. Uh-oh. I hit replace. Crap. Oh, replace all. Oh, Jesus. Find. There's only one. Okay. I think we can remove this. We can just comment them out. Compiler will skip that. Right. Can remove this. We're not stringifying anything. I'm thinking we could add a button and just emit something that says like center, you know. Home. Okay, well, we can do that later. We accomplished everything we wanted to tonight, so yeah, I think we're gonna go ahead and end the stream here. We can move the arms, which is dope. We've deserialized. Technically, this thing works. Few things to debug. One, the servo motor gets hot for whatever reason in the middle. Might need to just switch to a different GPIO. And add some like I want to make the slidable user input stuff on the web page. I want to make that easier to control. Right now it's like very small, so I want to figure out how to make those bigger buttons or something. And also like a center button, which will do nothing but send coordinates. That's all we should do. Now, we've gotten the basis down. I think actually, yes, we have gotten the basis down to where we just send positional data. Oh, something we need to do is wire. We need to wire up and move the DC motor. We need to figure out how to do that. Nasty. Okay. Let's upload this new code. Just going to test it one more time. What's up? Oh, it's writing. Okay. DNS started. Okay. Connected back to it. We're there. Seems to be moving fine. Nice little reset. I'll actually run into itself. Cool. All right. Until next time. Let's wait. Let's do the update subtitle. Yeah. Woo! We accomplished our goal.